Right, our task is to find the integral from 1 to 4 of root y minus y all over y squared dy. So I would have my students rewrite this, still the integral from 1 to 4 and still dy. But a trick of doing this is to divide each piece by the monomial. And remember, the square root is the same thing as to the 1/2 power. So you could subtract those exponents. 1/2 minus 2 is -3/2. Um, Still a minus, but then also divide the next piece. Uh, y to the first. Well, I would actually just leave that as 1 over y. You could leave it as y to the negative first. Let's actually do that real quick. Because if you follow your rules for the antiderivative, where you add 1 to the exponent, and then you multiply by the reciprocal of your new exponent. If you were to try that with this one and you add 1 to -1, you get 0, but 0 doesn't have a reciprocal. So it makes sense that there must be a different derivative, and that different derivative is natural log, and that's from 1 to 4. So at this point, you can plug in your upper bounds in for both 4s. And remember, the negative power makes this a fraction. So we're looking at -2 over, because of the negative exponent, and then it's a square root of 4. So that'd be 2 minus natural log of 4. And then you have to plug in your lower bound here and here. What's nice about the lower bound, though, is 1 to any power is just 1, because who cares? It's in the denominator divided by 1, square root of 1. So it's just -2 minus natural log of 1. Now, here's the thing is I expect my students to know without a calculator natural log of 1 is 0. So that kind of goes away. So as far as anything else goes, we're looking at -1. This turns this into +2. So we're looking at +1. I'm looking at the answer key as 1. And you can leave it as natural log of 4. I'm not sure why, but the answer key is correct that you could change 4 to be 2 squared. I'm just explaining why the answer key is what it is. And then the power rule says you can move this in front. It's a law of logs, if anybody's curious. That's why both of these answers are correct. So I'm circling them both. I'm telling you where I would stop, but you could keep going if you wanted.